Let me thank you first for being here, taking the time after lunch, digestion, so your effort is even more appreciated. Uh, they call it Masterclass. It's a very high-level word. I would like that take you in a journey and, if possible, take you by the hand through this journey. Before I start, how many people do not know Nidec? Be very honest. Do not know. Do not know. Only two do not know. Okay, so you avoided the 25 slides company presentation. So I will summarize this to less slides. So Nidec, until I joined it, I didn't know it neither. Okay, so I'm very honest. But we are having it in our daily life. Everyone has a smartphone. You already have something like 3 or 4 Nidec motors in it. And if you go to an oil and gas, most probably you have a Nidec motor doing the compression for the big gas manufacturing in the world. So Nidec is a company based in Japan that growed a lot by acquisition. Our business that we will speak about, Nidec conversion, is an acquisition that has been done 15 years ago, and I will speak a little bit about it. The numbers are here. I don't need to comment. It's a company that has been growing importantly, organically, and by acquisition. What we speak about is conversion, and what we convert is power. Okay, so that's what we do for breakfast, lunch, and dinner. We just convert power. We master it. We have been doing it even before Nidec. So Nidec is a 53 years old company, and we have been converting power for more than 60 years. Then you tell me, how come? Yeah, because it's an acquisition by Nidec of a company already converting power. So we have been doing this for decades, and what I'm showing you here are where does it apply? Which are the sector we convert power in? And when I say we convert power, it means we provide technology, we provide the people to commission it, we provide the people to service it if needed, pre-sales, after sales, doing the R&D, doing the engineering, and keeping it alive along the lifetime. We are in the eMobility, so we have an idea of what could be a lifetime of an infrastructure. I can tell you in metal industry, in oil and gas, we are still servicing installations that are 40 years old. Okay, so that's the lifespan we speak about. So these are the different, you can see, sectors where we do conversion, power conversion. In the last years, we have been very, very strong in the battery energy storage. 9 gigawatt hour already installed in the world, mainly in Europe. We are number 2 or 3 in Europe in terms of installation in battery energy storage. Remember this because it will have a link to what we will say about eMobility. And then in the power quality, hydrogen, electrolyzer, and we are here to speak about the electric vehicle charging infrastructure, which is part of the Nidec conversion. Manufacturing all over the world, and this is only one part. This is what we do, conversion, power conversion. So it goes from USA, Europe, North Europe, South of Europe, East, India, China, in terms of manufacturing capacities. So today, Nidec conversion represents $1 billion of sales last year, and 2,000 plus employees. I mean, the last time we counted, we were at 2,300. Just to say that when we start speaking about electric vehicle infrastructure, showing you what are the different installations across Europe, some of them are very interesting. We can tell a story about them, but just for the sake of time, if you want the story, we will say it at the end of the session. So, the title is about how the landscape is evolving, and it fits very well with the theme of this 3 days conference here. I mean, it is shifting. I think we passed the first wave where CPO, we're looking to have component, then sometimes having location, sometimes not having, sometimes having grid connection, sometimes not having it. And I think this first wave passed with, some companies that had very difficulties on the road. Since we entered this market relatively recently, we learned from all those, beginners in the market. And therefore, when we introduced the product, the journey started, and that's where I want to take you. From a customer request some years ago saying, I need to charge vehicles. I don't have access to grid. I have access to the low voltage grid. I need to charge that many vehicles, and I will not have access to medium voltage. So, Nidec, what can you do for me? So we collected our engineers and say, okay, what we can do is we take from the grid, we charge batteries, we use batteries as buffers, and when the vehicle comes to start to charge, we take from the grid what is needed more, we take from the batteries. That was the concept. And this is how we entered the electric vehicle charging infrastructure, by this door, I would say. We didn't enter it by a 60 kilowatt DC charger or AC because it's not where we come from. We convert many megawatt of power on every installation. So this is how we entered in this sector. So for us, it was like a natural evolution of our portfolio in the power conversion. And therefore, all this to say that today when we look in this journey, then we can discuss the number depending on which source so we are looking at. But if we look at the trend, we are expecting that in 2025, new cars, 40% in Europe will be EV cars. We are still far from China, okay? But it is increasing. What is new is those light-duty vehicles, electric ones that are also expected to be approximately 40% by 2030. Then 2030 is far, many things can change, but that's something quite interesting. Buses, approximately 20%, and e-trucks, 13%. So we take those numbers as facts. We will not debate them here, but we take those numbers as a fact. What is changing when you look at the heat map? No surprise. We know that the biggest countries today in Europe are France and Germany, and growing. Then if you look at percentage growth, if you start from very low, you have high percentage of growth. But the heat map shows this. The interesting point here is that there is 80 electric vehicle per DC connector. Okay. There is a rule of thumb that 10 EV, 1 connector, but it takes into account the AC. We look a lot at the DC because that's the new trend now, because the cars' batteries are getting bigger. Cars are expected to have faster charging. Not only cars, but any electric vehicle is expecting to have a faster charging. Then the other change is the growth of the battery electric vehicle versus the plug-in or the hybrid. Then this is another way of showing it in terms of penetration, but you see that the low commercial vehicle, medium commercial vehicle, and high. So you can see dark green, light green, and I don't know this color, dark blue, and light blue growth. So when we look at those numbers, we say, okay, what the market is doing about it. We Nidec, we don't produce electric vehicles. We do infrastructure, but how we adapt our offering, how we adapt our portfolio, how we adapt our organization to fulfill this need. Okay, and this data is available. I think Bloomberg, so you can have access to it. Then the interesting point is, for those kind of vehicle, how many connector there could be. When we look at this, it's not to say this is our forecast of sales or forecast of installation. It is to say what technology could fit for every case. And all my story today is about there is not one technology or one system that fits all. Okay. So if there is one takeaway is that there is not a 120 kilowatt fits all, there is not charger with battery that fits all, there is not a portable charger that fits all. It depends on every time on the case you have. And this is where I said the first wave passed, where we put charger all alike, and then we might have a low utilization rate or low reliability, where now it's no, okay, that's my case, this is a problem I want to solve. You come to us, or to somewhere else, better to us, and we try to see how we can solve it. So, I was at the event of Hubject yesterday evening, and one of the topic was, okay, electric vehicles. Okay, infrastructure. What about grid? And the answer was, at 2030, the electric vehicle will take 4% of the grid, of the total grid. It's not a lot. But it's starting from today, 0.3% of the grid. Okay? So 4% doesn't look a lot, but going from 0.3% consumption to 4% consumption, grid power supplier have to take this into consideration. Okay? Does it mean they have to increase, or is it on behalf of something else? Okay, maybe providing less power to gas station, just to compare things in the same field. So that's an important point. And you probably know that designing a new vehicle today, time to market can be 2 years. In UK, installing a medium voltage station can be 3 years. So it's faster to design a new car than providing a medium voltage connection in UK. Okay. Cost, I'm not saying is comparable, but we can speak about it. So we should think about the grid. We should think that if there is a utilization rate of 15%, do I really need to have a medium voltage connection because one day might come where I have a utilization rate of 25%? And this day will be the summer peak holidays in south of France? So this is when I say there is not one system, one solution fits all. We look at the cases, and then we try to come with the most appropriate configuration. And this is where the engineering part of Nidec enters, because we are engineers, so we like always problem solving. And due to grid limitation, there are CapEx investment. If I am a CPO, I will look 3-4 times before investing this. Medium voltage, we can look at figures later. And this is, as we said, for big demand. So one day will come and I have to be able to provide it, and therefore I have a big CapEx at the beginning. And last but not least, one thing we saw is that when medium voltage cabinet is installed, it's not the property of the CPO or of the landlord. It's the property of the DSO. So if the site after 2-3 years is not bringing the result, you already invested in this medium voltage station. I'm not against it. I'm saying every case we have to look at it, where best to put the CapEx. So we did many comparisons. I'm sharing with you one case. Okay, so you can ask me a question at the end why it is to have a medium voltage connection is 12 months to 24. In some cases we get it in 6. That's fine. We can discuss it. That's one case we are sharing with you. So low voltage connection, depending on the countries, can vary from 3 to 12 months. Power range, again, depending on the countries, it's up to 250 kVA. In some countries it's 150, in some other it's 250. Complexity relatively low, involvement of the DSO I guess it's not for me. Okay. Involvement of the DSO standard, permits quite quick, cost few thousands of euro. Probably you need to pull a cable of 10 meter, 15 meter. Grid impact studies, depending on the country, typically is not required, unless, we will speak about it later, we do grid services, meaning if you put battery, you give back to the grid, okay? And infrastructure need, you can see here. Medium voltage connectivity, we did this case with a customer, by the way. We've put the range, in this case of customer, it was very precisely 180,000. And it requires the DSO involvement, meaning lead time for answer, complexity, etc., etc. Again, it is feasible, but it's not the same type of effort, and I do not neglect the lead time to have it installed. Okay. So, if the grid is the bottleneck, I'm not saying the generated power in a country. I'm saying the grid, accessibility to the grid is a bottleneck. What do we do about it? We limit to 60 kilowatt charger, 120, and we are okay. What if the need is higher? So many people will say, we start with 120, we see the utilization rate, we see the traffic, then we upgrade. And we can say, okay, but what if you consider, and I will tell you how it works, what if you consider to put battery in between? The battery is a buffer, okay? The battery is your freezer at home. When you come back and there is no food, you open the fridge and say, I can defrost it and use it immediately. That's the battery, okay? So how many people at home have a fridge without a freezer? You all have a freezer, right? Okay, so it's good to have a buffer somewhere. And not same investment, of course, but you have to compare to what if I have to connect to the medium voltage. So it's on PowerPoint, but it's real test with the car. So try to follow me. If it's not clear, stop me. We took the same car. We had an installation connection to the grid, 100 kilowatt, low voltage. We have a 279 kilowatt hour battery systems. And we did the same exercise without the battery. Same car, came with the same autonomy, left with the same autonomy, only connection to the grid, okay? So, the car left with the same autonomy in both cases. In one case, it took approximately 1 hour, 100 kilowatt grid. With the batteries, it took half the time, approximately 30 minutes. Why? Because we use the 100 kilowatt from the grid, and we use the battery to give the complement for the car. So the car came, was able to charge at 270 kilowatt for half an hour, finished, went out. We took from the grid this green power, so 100 kilowatt. The state of charge of the battery, not of the vehicle battery, of the charger battery, okay, was consumed. And then after approximately 1 hour, the battery was full again. Here, let's take a charger with two charging points. You serve one car, you cannot serve another car for 1 hour. Here, you serve one car for half an hour. Another car comes here, you can serve it. Another car comes here, you can serve it. Okay. So that's mathematics, scientific. We can debate it, but this is how it works. Then we took another case. By the way, here you are still on low voltage, so you are not requiring medium voltage, etc. Another case is you have a 400 kilowatt medium voltage connection because the site has it. You are on a site that already has it, so fortunately you have it. That's fine. You say, okay, I don't need to invest in batteries. That's fine. If you have it and you invest in battery, you still can serve here one car. It takes half an hour because you have the 400 kilowatt accessibility. When you do it here, you can serve two cars with the batteries. Now, if the utilization rate is 5%, you can take the risk of saying, okay, what is the likelihood that I have two cars at the same time on this charger? If the utilization rate, peak time, etc., is higher, there could be a likelihood of two cars. Okay. So again, I'm not saying it's battery or nothing, battery charger. I'm just saying every case has to be analyzed, studied, and then we try to find what's the most appropriate between CapEx, OpEx, utilization rate, traffic, type of vehicles, because we will speak in a short while, about heavy-duty vehicles, commercial vehicles, where the need is a bit different from, our private electric vehicle. Now, so we put ourselves in the shoes of investor. Where do I invest? Do I invest in a medium voltage, no batteries, and it has a cost? Or do I invest, I don't care about the medium voltage, I remain with my low voltage, I invest in higher CapEx because the charger with battery has a higher cost because there is more hardware and more software in it. And what will be my return on investment in terms of cash flow? We took two cases, and these are cases we did with, I will show you the picture later, with one customer 2 years ago. And after those cases, he installed 5 sites. I will share with you later. Okay. So, based on 10% utilization factor or 15%, we see that the cash flow, meaning coming back to a positive cash flow with a charger with battery, year 5 approximately. In the other case, investment in the medium voltage station. By the way, subscription to medium voltage in certain country, you pay more the kilowatt hour when it's medium voltage than low voltage. When we integrated, so this is the case what we studied. You have 3 years difference when you start generating cash, and you don't catch the gap. You don't catch it. So from an investor point of view, someone has to sit and say, is it about CapEx or is it about the total cost of ownership of my installation? And this is what I believe personally. I've been long enough in this industry to see that all of us, we should start speaking about total cost of ownership rather than CapEx, your price is here, the other price is here, what can you do? Okay? Because this is what they did in the photovoltaic 20 years ago, and 90% of the company disappeared. Okay? So, I have more white hair than all of you here aggregated. Trust this experience, okay? We have to speak about total cost of ownership. If this is the business, we are looking on the long term, okay? If it's a business we are looking to do and to resell, okay, that's another topic. But if we are looking really as real industrial people, we should look at the total cost of ownership. When there is a higher utilization rate, the cash flow is 3.5 years with the batteries and approximately 5 years connecting to a medium voltage. Okay, so there is still a gap. They never cross. They never cross. It is when you want to start generating, and of course, you take 20-25% utilization rate, then the return on investment in terms of cash is faster. So this is summarize a little bit what I've been saying. I take it just because I see you are taking pictures, so you can take it. What are the benefits? So as I said, no extra grid costs. You just connect to the low voltage. You anticipate the revenue because you don't need to wait for the installation of the medium voltage station. If you do grid services in certain country, you can generate revenue from that. And why we are saying this? Because we have more than 12 years of experience in utility scale battery energy storage. And we know what is grid service. Okay, 12 years and 9 gigawatt hours, so this is why you could do grid services with this. Then it can integrate with PV. I will show you an example. We spoke about lead time. You keep the property, meaning it's a cabinet. The day you see the location, let's assume the location is not yours anymore because you rented it for 3 years. You dismount, you install it in another location. If you have medium voltage connectivity, you cannot dismount the medium voltage station and take back the cable of 1 kilometer that were laid in the ground. One thing close to my heart, personally, is that in our concept, when we take the power from the grid to charge the battery, we do one conversion. AC from the grid to the battery, DC. We deliver it to the battery vehicle only in DC. We don't do other conversion. What does it mean? It means I avoid reducing the efficiency because we stay on the same DC bus. If I'm an operator, I buy the power at, I don't know, whatever, 20 cents the kilowatt. I sell it at 65 cents the kilowatt hour. If I lose 2-3 points of efficiency more, it's loss of margin. If I avoid losing it, I still sell at 65, I still buy at 0.2, but I deliver 2-3 points more of energy efficiency. Again, it is not magic. Huh? The less you do conversion, the higher the efficiency is. Okay. We don't do something magic. It's the concept of our architecture. Why is this? Because we have engineer that knows how to convert power. Then, okay, I leave to Andrea and the team, product manager, to tell you what are the features, but we can go up to 2.2 megawatt hours. So again, every case is different. We have installation of 5 installation of 2 megawatt hour each because the customer had photovoltaic grid, wants to charge all his vehicle at night. So it's a fleet. During the day, they do the delivery, and at night they need to charge. So he wants to accumulate all this power, and in 6 hours at night, he have to charge 48 vehicles. And he cannot not charge them. Otherwise, there is no Amazon delivery the day after. In his sector, not in all Europe. Okay. Okay. That's the concept we did with this customer. I said we did the analysis with him. By the way, it's in Italy, so you are welcome to visit. Where his case was, because I was in the first meeting with him, and when we came with the final design, he said, I can put photovoltaic that's much peak over my garage. I don't want to have medium voltage connectivity because it's very difficult to have it in his sector. I mean, in the region he is in Italy. I have 48 vehicles, no, he initially 24 and then moved to 48 vehicles that come at night at 4, 10, 11 in the evening. They need to leave at 4. They charge until 5, and 5 they are on the road. By the way, Nidec, the return on investment should be less than 7 years. That was the case. So, we engineered all this. And that's the installation 1 year later. So, in this case, we delivered the container with the batteries, with all the conversion inside, so one container. The day he doesn't want, he takes the container and put it somewhere else. Then that's the photovoltaic. That's one charging, that's for the CEO, because he wants fast charging for his car, or some trucks that needs fast charging during the day. e-vans or truck that needs fast charging during the day. What you don't see is under here, the 48 charger for the e-vans. Okay. So, long story short, over 1 year, he consumed half a gigawatt hour of clean energy. Over 1 year, he almost charged all the vehicle free of charge due to the photovoltaic. Why I say? Because in January, February, less light, so we were able to charge less the batteries during the day, and he had to use the grid. When there was enough light, daylight, we were charging the battery 2 megawatt, and when the vehicles were coming, they were charging free of charge. Great, yes? They did 823,000 kilometers clean energy. So I calculated it's twice the distance from here to the moon in 1 year. Clean energy. One site, huh? Just one site. They have 5. And as I said, they were almost independent of the grid for this. Why 2 megawatt batteries? Because that was the best compromise between capex, return on investment, charging needs. Can be 1 megawatt or can be 300 kilowatt hour. Okay. If you ask me, I don't know. It's every case is different. And this would bring us, that example was 3 years ago, bring us, okay, how do we handle commercial fleets? How do we handle depots? And again, we come to the situation that I'm trying not to do a selling speech here by saying that's our portfolio, etc. We say, okay, what do they need? They need night charging, doesn't require to be fast. Day charging has to be very fast. How we combine both on the same location? How do we handle not enough parking places for the charger? So we said, okay, we can do mobile chargers. Because if the trucks or the bus or the event cannot come to the place where there is the charger and somewhere else and still need to be charged, we have to think about a mobile charger. Okay. So all this to say that with this approach where, okay, we call it split because you have the power conversion on one side, as I showed you, like a container. It's not always a container. Huh? If it's smaller, it's a cabinet. And the charging point close to the vehicles or close where they can park the vehicles. And therefore, you can do it very modular. You start small, and then you increase based on your installation. So I always like to say that the conversion part is the hidden part of the iceberg. It's the thing we don't see. It's in a cabinet. This is what can cost you or make you gain a lot of money. Energy efficiency, reliability, uptime. We were speaking. Okay, that's an example. I will let you look at it, but and I'm looking at the time. So I was reading the introduction of Object for this event and saying that users are moving from range anxiety to charger anxiety, meaning I arrive to the charger, but the charger is not working. So I have enough autonomy to arrive to the charger, but the charger is not working. So charger anxiety. Yes, of course, it's about reliability. And reliability starts from the design and you start from the power conversion. What the user sees is the charging point, but it starts from the power conversion. Highest efficiency possible. Because every time they charge, if you have an efficiency, energy efficiency of 96, 97%, gentlemen and ladies, end to end, okay? Don't look at the power module doing the power conversion itself. You have to look at the end to end, from the grid to the car. That's the energy efficiency. Okay? And very few look at it. Very few look at it. And as operator, you can imagine how much you can lose in between every time you do a charging. So just to look at it from a different approach, because there is no one size fits all, like for clothes or shoes, there is not one solution fits all. So we entered this sector, this market, by having, what is it? Batteries, power conversion, chargers. And this is where our entry in the market. And we expanded the portfolio to go from 2 times 30 kilowatt up to 1.3 megawatt. Okay, so that's the journey that brings us here. And I'm looking at the time, so we have 5-6 minutes for questions, or after for the people that are shy or that doesn't want to share sensitive information. We don't have a micro to share, so I would if you can speak. I need to come. Yeah. Yeah. Yeah.
There was a moment where the battery was flat.
Yes.
What does it mean? Change of the cell? Or?
You have a very, very good remark. It's a point where you replace.
Okay, the point where
You replace.
it was like 7 years old.
Exactly. We are very honest with the, so battery had the lifetime, so they lose, or you over dimension. It's better to replace than over dimension. It's better to replace than over dimension because you over dimension and you don't use it. Okay, so it's better to replace. Very good remark. Yeah. I will repeat because maybe the service, do we do it in-house or we subcontract? Depends. We have our service organization that is since 60 years because we service all the kind of industry we are serving. And I can tell you, a metal factory, they don't like to stop. Because stopping not forecasted means hundreds of thousands of losses. Nothing comparable with a charger, nothing, okay? Gas is worse. Gas is worse. So, yeah, we have our service organization. In some places, when you need a fast reaction, we work with service providers because they are closer. Thanks for the question. We collected all the data since the first installation. 85 to 90% of the problems we face, and if I tell you we face no problem, run away from here because that doesn't exist, we are solving it software remotely. So we have a team. When there is a request, they look at it and solve it remotely. So you don't have to send someone on site or wait for the availability of the site, etc. The questions are from the last row. Is it related or? Okay, so thank you all. Thank you for being here. It's warm, so thank you for also suffering the warm with us. And if you have other question or you want a one-on-one, we have a very, very small booth next to the entrance. Okay, Nidec green. Thank you all. Bye-bye.